Hello guys, you are with the Tech Science. Today we are discussing one more type of telescope. It is called Cassegrain Telescope. Since couple of days we are discussing the chapter Observing Space Telescope, which is basically from the 9th standard of State Board of Maharashtra, and we are this first telescope that we are discussing is called optical telescope, in which lenses are used to observe the heavenly object. Then because of that, some of the problems are there, and because of that we are discussing one more telescope. It is called Newtonian telescope in the last lecture. Today we are discussing new telescope. It is called the Cassegrain Telescope, and this Cassegrain Telescope here, this is the name, Cassegrain Telescope. Okay, and the Cassegrain Telescope is based on, of course, it is a mirrors are there. As we discussed, there are the three drawbacks are there in the optical telescope. First drawback is regarding the size of the lens. Why? Because whatever the objects which are coming, for example, observe, these are the incident light rays are there. Am I right now? So these are called incident light rays. So these incident light rays are coming from the heavenly object, and if you have to collect the maximum amount of light rays, we require the more number of lens, large lens, large in size, and it's very difficult to make a very large lens. Second, the distance between objective lens and the eyepiece lens is we have to keep it is large, and because of that, maintenance problem is also a kind of problem. That is what the second drawback. And the third one is out, there is a problem of color of errors of colors. It is called the chromatic aberration, and because of this we are discussing to solve these problems we are using the mirror. Observe here what kind of mirror we have in the Cassegrain telescope. First, that is called objective thing. Here we are discussing as a concave mirror. It is nothing but called as the objective, main thing from where actually the light sources are coming from the heavenly object, they fall on the concave mirror. So this is what the primary thing. After falling these incident light rays from where, observe, these are parallel to the principal axis, and these are called incident light rays. Observe, this is what second incident light rays, and when they fall on this mirror, what happen here? Of course, it is a kind of concave mirror is there. In concave mirror, convergence occur, and what happen here? The light rays are reflected back, and they meet at a point, and this point is called focus. Am I right? This point is called focus. So somewhere you got here, this is the point called focus. It is called F. But before the light rays which are meeting at the focus, before we place a convex mirror in front of them, where exactly, observe, this is the focus, but before this we are using a kind of mirror. Observe here. So we situated, before light rays are meeting to a focus, we place a secondary mirror in front of this concave mirror. And here the small, convex mirror, it is a convex mirror. So here a small convex mirror we are using, and this convex mirror placed in front of this concave mirror. Now what happened here? Of course, it is a convex mirror, and in convex mirror the light rays are incident from this. Am I right? Those light, observe here, those light rays which are reflected back, which are bounced back from the concave mirror. Now these rays are nothing but input to the convex mirror. I am repeating my sentence once again. Observe, this is what the input. Am I right? This is what the input. This is the input for. This is the input for concave mirror. It is called primary mirror. Am I right? And after falling these light rays on this concave mirror, they get reflected back. So this is what the reflected rays are there. And now these rays are nothing but the input to the small convex mirror. So reflected rays of concave, nothing but the input to the convex mirror. Now we know that what happened here. Now here this input rays are there. Which input are there? Observe, these are the input rays are there, and we know that these are the input rays for the convex mirror which are reflected from the concave mirror. Now they get diverged, and they meet, they pass through this point. So this concave mirror, it having the small hole. Observe, where there is a hole, this is the hole, and these light rays which are reflected by this convex mirror, they pass through this small hole which is in having the concave mirror, which is held in between the 2 points of this concave mirror, and when they are passing through this hole, in front of them there is a convex lens is there, and that is called eyepiece. And we know that when rays are passing like this in a straight manner, which is parallel to the principal axis, what happened here? Here the user is situated just behind the eyepiece, and here it got the magnified image. It got the magnified image, and we can see a clear, bright and magnified image by the heavenly objects which are coming from where the light rays are coming from the infinity. So this is what the construction and working of the Cassegrain telescope, where of course the same like advantages are there. What are the advantage that we are found in the Newtonian telescope? Example, because of the mirror, the cost of this telescope is somewhat low as compared to the lenses. Second, the problem of the main thing is what? Second point, the problem of chromatic aberration, that is called error of color, that has been solved by this Cassegrain telescope, and the weight of the large mirror is also less than that of the lens. That's why there is a very easy to maintain such kinds of telescope. So this is what the today's point, the construction and working of the Cassegrain telescope. I hope you like the video. If you like the video, please subscribe my channel and press on the bell icon for the new notification. Thank you.